Would you like to learn about BGP? If so, this video is for you. Hi, my name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects, and we're an organization dedicated towards building high-performance cloud computing careers. I've been working in technology for over 25 years, and I've been coaching or mentoring others to get their first tech job or get promoted in tech for over 2 decades now. Now, talking about BGP is something that's near and dear to my heart. I come from the original networking world. I'm one of the original Cisco certified internet experts, and BGP is fun. This video on BGP is the second, and it's the subsequent video to the previous video we introduced last week, which was also about introduction to BGP. To recap what we covered in the previous video before we get started with this video is what is BGP, why is BGP used, and how BGP works. We talked about that a lot in the previous video. We discussed the protocol, the finite state machine, the BGP message types, and how BGP selects a path. In this video, we're going to talk about optimizing BGP, where we're going to do a couple quick refreshments to make sure that everybody still remembers the video last week. So remember that BGP is a TCP-based path vector protocol, which means it sets up a TCP session and it lets you know the path or the number of autonomous systems it traversed. BGP uses TCP port 179. Remember that, because if you've got any kind of firewalls, you need to make sure that the firewalls permit TCP port 179. BGP is used due to its scalability and tunability, and that's why we're going to talk about tuning it today. And BGP is always used to connect to external organizations, since when you're on the cloud, for example with AWS BGP, you're connecting to AWS and they're not inside of your organization. They'll therefore be a different autonomous system, and that's why we're using BGP, because we're connecting to external organizations. Let's rehash the path selection process, and then we get into the fun of tuning BGP based upon the tenets of this path selection process. What is the path selection process? First and foremost, choose the route with the largest weight. And if the weight is not set, choose the route with the largest local preference. And then choose the routes that were originated on the router, meaning you originated here versus learning somewhere else. Then choose the path with the shortest number of autonomous system hops. We'll show you how you can tune that. Then choose the path with the lowest origin code, meaning like IGP versus EGP versus incomplete. Then we'll talk about choosing the path with the lowest med. We'll show you how we do that. And then it goes to things like choosing an eBGP route over an iBGP route, because it's typically more preferable. And then we get into some older things where we're talking about the neighbor with the lowest metric and lowest IP address, and that's where we're going to stop here. You have to have something that can win the election to provide the best path, and that's why we have all these metrics. Today we're going to talk about the things that we're typically going to be tuning to improve BGP performance. Now let's say you have 2 connections to AWS. If you've got a direct connection, theoretically their direct connections are highly available. And what they mean by that is you're connecting to a virtual router and to availability zone, which is great. But what happens if your direct connection fails? Then you've got a problem. Or if your router fails, you've got a problem. So when you have real high availability needs, you're going to use 2 direct connections and then VPN backup. And you're going to be running BGP on both direct connections. Now you could block one path and only use one, which they typically teach on basic networking things like in the AWS Advanced Networking curriculum. But if you're going to be a really good cloud architect and you're used to doing design, you should be able to load share across multiple links, bring better performance, better systems, and not have any type of out-of-order packets. So we're going to teach you how you do that. Now, BGP routing is bidirectional. What do I mean by bidirectional? I have to tell my upstream neighbors about me, and they have to tell me about them. If they don't tell me about them, I won't be able to reach them. And even if they can reach me, my traffic can't go back to them. So with BGP, we're always talking about bidirectional routing. Now, in the examples we're going to use, we're only going to show it from one side. Why are we going to show it from one side? We want to make it as simple as possible. And this is part of a networking series that we're going to be doing. So we've got to start somewhere. So let's take a particular example. The easiest way to basically load share across multiple links is to do it with routing outside of BGP. What do I mean by this? If you can look at the diagram that we show you here, note that we have 2 links. Note that the organization's data center is using the CIDR range of 172.16.0.0/15. Now, realistically speaking, that's multiple subnets that we can place on here. So let's say, for example, we have two routers in our data center. And on the top router, we desire to tell the cloud that, by the way, to reach the 172.16.0.0 subnet, take the top link. And then what if we tell the cloud provider on the bottom link to take 172.17.0.0/16? Use the bottom link. What have we done? We've created a specific link on the top and a specific route on the top. And guess what? The top link will be used to reach 172.16.0.0/16, and the bottom link will be chosen to use 172.17.0.0/16 because we leaked those routes. Everything will work perfectly until we lose a router or until we use a link. Now, whichever link we haven't shared, a subnet we haven't shared, will not be reachable. So what do you do when you do an environment like this? You do the following. As you can see in this diagram, what I've done is I've sent the specific link on both sides, and I've sent a summary link, or the CIDR range, on both links. And what'll happen is the CIDR range isn't going to be used because all the traffic is going to be using the more specific routes. And if we don't have enough specific routes, we'd have to modify one of those CIDR range things, but let's not get there for here. So the point is, in the top link, we've got a specific one, and the bottom link, we've got a specific one, and we've got an aggregate or summary address, which provides reachability for everything. So look carefully, 172.16.0.0 and 172.17.0.0 both/16s can be summarized into 172.16.0.0/15. So by sending that, we're always going to work. The top link goes away, the bottom link will have the more specific route and the summary route, so everything is reachable. So this is typically the simplest and most elegant way using BGP to load share across redundant links. Now, the next simplest thing is to adjust the weight. So as I mentioned, on these routers, if they support the wait feature, which a lot do in today's point, it used to be a Cisco proprietary, but a lot of the cloud providers support it. So what does this really mean? If you on the receiving end, as you take in routes, you can say, increase the weight. And if you increase the weight for a certain subnet, that will become the primary path. So what did we do here? On the AWS side, we increased the weight for the more specific subnet, and we increased the rate on the bottom link for the more specific subnet, and on the summary links, we kept the weight even. Therefore, we prioritized 172.16.0.0 traffic going on the top link, and 172.17 traffic going on the bottom link, as you can see in this diagram. And if either link or router were to go away, no big deal. The summary route, or the aggregate route, or the CIDR range will take care of your network layer reachability information. Now, let's say we don't want to use the weight. Let's say we wanted to do it another way. We could take these incoming routes, match them, and then raise the local preference for one side for a route that we want to take, and do the same thing for the other route. So look what we did in this diagram here. In this diagram, we took our primary subnet on the top link, the 172.16.0.0/16 that we wanted to use. We changed the local preference. We increased it to 200. And we did the same thing on the bottom link for the 172.17.0.0. We raised the local preference for that specific subnet. We kept a standard local preference for everybody else. And that way, more specific subnets are going to be used. And when one of those links goes, your traffic will take the aggregate route. Simple, elegant, effective. I mentioned BGP as a path vector protocol. And what happens is every time a route is learned and it traverses an internet service provider or an autonomous system along the way, or a customer organization, the path that it's added gets added. So what happens is, for example, let's say we just have a simple BGP connection between our data center and the cloud. Let's say, for example, our data center's autonomous system is 64523. Let's say that's our autonomous system number. When the cloud is going to receive it, they're only going to receive one hop, or 64523 of the autonomous system number. And it's going to receive that on the same link, but top and bottom. But what if we wanted to make one route look ugly and another route look good? We can do that. So what we would do is we would take the route that we choose not to use, and we would make it look less attractive by prepending or adding another AS path. So what if we just prepended it? If our AS is 64523, and we added or prepended another 64523, as you can see we did in this graphic, now that link looks extra hard to reach, for example. So that's why we did these kind of things. We make one look really good, and we make another link look really bad, and then we're always in the position where we can provide packets getting in the correct order, getting to their destination, and load sharing. The last way that we're going to show you how to do this is by manipulating the MED, or multi-exit discriminator. realistically speaking, we can lower the med, and by lowering the med, we can make a path preferred. So as you can see on this diagram, again, what did we do on the top link? We reduced the med for the primary route we want to pass, 172.16.0.0/16, and the summary route, we kept it the same of 172.17.0.0/15 of 100. So because by doing that, the 172.16.0.0/16 will be preferred on the top link. Now on the bottom link, we made the 172.17.0.0/16, we reduced the med, so that's going to be the preferred link. And on the aggregate route, we haven't changed, or the other side, we haven't changed anything. And by doing this, we made it very clear, preferred path, backup path. BGP is a marvelous routing protocol. People use BGP because it's tunable. You can easily engineer traffic just like we showed you how to do it. We showed you a few ways to do it. We showed you how to do it by leaking a more specific route. We showed you how to tune BGP by manipulating the weight. We showed you how to tune BGP by changing the local preference. We showed you how to change BGP or optimize its rating by prepending an autonomous system path. And we showed you how to do it by changing the med. We've covered a lot about AWS BGP and BGP routing protocol in general, as well as BGP for cloud computing and all kinds of cloud networking concepts in these two videos. But that's not enough. Networking is absolutely critical for your cloud architect career. Let me tell you about something we're doing to help you out with that. On the week of July 13th, 2021, we are going to be holding a completely free AWS Advanced Networking Bootcamp. And I've been working in networking for 25 years. I'm one of the original Cisco certified internet experts. My number is 7417. And I got to tell you, I love talking about networking. Had a great career at Cisco as well as lots of other wonderful companies. And this is going to be a fun week. We are going to cover networking in our AWS Advanced Networking course, unlike anyone else out there, because we're networking professionals. And we're going to make sure everyone learns the network. What is the cloud? It's a virtualized network in a data center. And we want you to understand the network and be great at it. So we're going to be doing that soon, and I highly recommend everybody join us because cloud architects need cloud network training. Additionally, some things that we do at Go Cloud Architects to help the community are on every Monday and every Thursday. We have a completely free How to Get Your First Cloud Architect Job webinar. And when you come to these webinars, we will teach you everything you need to know to get hired. We will tell you what should be on your resume, what a hiring manager desires, the kind of experience that'll get you hired, and much, much more. It's completely free. Attend on Monday or Thursday. The link is in the description below. Also, every Tuesday we have a Cloud Architect Experience webinar. We give you the experience of what it's like to be a cloud architect just for a day. You can use this to see if you're job ready, and I promise you, you'll either learn something or you will know you're job ready, or if you're not, you're going to know exactly what you need to do to get hired so we can get you hired as a cloud architect as soon as possible. Most Wednesdays, but not all, we do a free Cloud Architect Career live stream on YouTube where you bring us any cloud architect career question you may have and we answer them for you real time. We want to do everything we can to help you get cloud computing hired or cloud architect hired based upon the cloud computing career of your dreams. If you're working on your certification, we've got lots of free certification training to help you. We have a completely free AWS Certified Solution Architect Associate ebook and full course. The link is in the description below. We have a completely free AWS Certified Solution Architect Professional program. Again, the link is in the description below. And we are hosting a completely free AWS Advanced Networking course. The link is in the description below, how to register for that course. And we do many, many more things like that. Thank you so much for watching this video. We're excited to speak with you every week via YouTube, and we hope to see you soon. Take care.